Hi guys, how's it going? So today we're going to be looking at this question called target indices. So we are told that we're given an array and a target integer. So we need to write a function called sum pair indices that returns the indices of two integers in the array that add up to the target integer. If not, we just need to return an empty list. And we shall solve this question in linear time of n. Right, so even if there could be multiple solutions, we just need one solution to be returned. So we need two integers that sum up to target, right? Two integers. So essentially what they're saying here is that for instance, you can see that 2 and 3, they sum up to 5. Also there is 1 to 4, they sum up to 5. What is the integer of 2 and 3? It's gonna be 1 and 2, and this one is gonna be 0 and 3. So that's what you return here. You can either return this or this. So now let's see how we can actually go about solving this target indices problem. So let's imagine that we have 1, 2, 3, 4, 5, 6, 7, 8, right? And we're trying to sum up to 5, right? That's the target. Remember that we want two values because they said we want two numbers that sum up to the target. So we want two numbers. So we're going to use this technique that they call two pointers. So you have a point here at the lower index and you have a point here at the higher index. I'm going to explain the intuition behind this so that you understand why we have this, right? But the point here is that you have a pointer here at the low index and you have a pointer here at the high index. You add these two things, what do you get? You're going to get 9. So 9 is definitely greater than 5. What are you supposed to do? You're supposed to then decrease this value here, right? Why are you decreasing the one at the high? Remember that you want to reduce 9. 9 is high, so you want to reduce it so that you get to 5. So imagine if you increase low, then you're going to increase 9, right? Because now you're going to go to 2, you're going to now add up 2, right? So you don't want that. You instead want to decrease this. So now you're going to go to 7. What are you going to get? You're going to get 8 because of 1 plus 7 is 8. You decrease this. You say, no, I don't want 8 is still greater than 5. So I want to go back. So you go to 6. What do you get? You get 7. So no, 7 is still greater than 5. You go here. You go to 5. You decrease the pointer. You go to 5. You get to 6. So 6 is greater than 5, right? Then you go to 4. So you say 4 plus 1. It's like, yes, 4 plus 1. This is 5. So what's the index? 0, 1, 2, 3, right? So you know that, okay, 0's index, which is the first pointer was pointing to, and this pointer here, which was pointing to 3, this is my output. So it's going to be 0 and 3, right? Now, you're probably wondering, why are we using these two pointers then? The intuition is that we're controlling this maximum value here. So you can imagine that if we were trying to sum up to a very high number, right? Let's assume that we're trying to sum up to 10, for instance. Let's assume that we're trying to sum up to 10, right? So when we started, you started at 1 and 8. So 9, it's small. It's small. We need to get to 10. So what does it mean? Do we have to reduce this pointer? No, we can't. Because if we reduce this, you're still going down. You will never get to 10. But instead, you want to get this one to go up. So when it goes up, it goes to 2. So 2 plus 8, it's 10. So now you're matching this guy. So you have 2 pointers that point to the total. But they really, it comes down to, really the algorithm, honestly, it comes down to you making sure that as you shift these 2 pointers, they call this technique 2-pointer. There's I think it's 2 sum, 3 sum, 4 sum. on LeetCode they call this problem two sums. Yeah. So but you kind of like shift these to control these value to match to the target. So now I'd like us to code this thing up. So now let's code this one up. So we told that we should solve this in linear time. So in one for loop we should be able to do this, right? So so I'm just gonna say right, because we said that we have to start at the first index, and we said that we have to start at the last index. So it's gonna be, we're just gonna shift them around, right? So what we need to do is we're gonna to say while left is actually less than right, because we don't want these to cross, right? Doesn't make sense for them to cross. So we're gonna say current sum is gonna be equals to array. So we're taking left, right, and we're gonna add array, we're taking right, right. Then we check if the current sum, if the current sum equals to target. If it is, then I'm just gonna return the index. These are indexes, left and right are indexes, so I'm just gonna return them. So it's gonna be left and I'm gonna return right. However, if they're not, I'm gonna say else if current sum is actually greater than target. So it's greater than target. What I want to do is that I want to take my r right minus equals to 1, right? Remember that, like I showed you, is that if you have a bigger value that is greater than target, so what you want to do is that you want to reduce the right so that you kind of like lower it down. So that's why I'm subtracting it by 1. So similarly, you have to do it with the left. So it's gonna say if current sum is actually less than target. So what you want to do is that you want to say left plus equals to 1, and when you're done, you're just gonna say return minus 1. So I'm just gonna hit that submit button, and it works. Submit solution. It works fine. So yeah, I think that's all, guys. I really appreciate it for tuning in. I'll see you in the next time.